So good morning, everybody. I think we've still got a few people joining, but I think we'll get started because we've got a lot to talk about today. Welcome to this Royal Aeronautical Society webinar, where we're going to be launching the annual report from the Greener by Design Committee. My name is Naomi Allen. I'm the Head of Research at the Royal Aeronautical Society, and I'm going to be chairing the session today. Just a few sort of housekeeping announcements. We are recording the event and it will be sent to anyone who registered for the webinar after the completion of the event. We are planning to have plenty of time for questions from the audience. So if you can post your questions into the chat as we're going along, and we'll keep an eye on those. And when we get to the Q&A section at the end, then we'll try to cover as many of the questions as we can. And the webinar is planned to end at 1 p.m. So this is part of our Sustainability Week that we're running at the Society. We're trying to cover quite a lot of sustainability related content, and it seemed a really good opportunity for us to share the work that the Greener by Design team have been doing in preparing their annual report. Quite a lot of work goes into this every year, and there's some really interesting content that we wanted to be able to share with all of you. So we've got two speakers from the Greener by Design Committee with us today. Unfortunately, Jeff Maynard, who's the chair of the Greener by Design Committee, is unwell, and although he's on the mend, he's unable to be with us today. So we won't be covering the sections around operations and SAF. So we'll mostly be focusing on the technology part of the report and also a little bit about contrails. So covering the technology section, we have Dr. Richard Wilson. He has had a 30-year career in aircraft design, operation and performance, and has gained considerable experience working in globally recognised industrial, academic and research organisations, many including significant airline contact. Richard established RAW Aviation Consulting in 2017 to deliver similar service activities to the same broad range of organisations, and sometimes now acting for the airlines. And our second speaker will be Professor Ian Paul, who's an Emeritus Professor of Aerospace Engineering at Cranfield University and CEO of Paul AeroSciences Ltd. He's worked in both academia and industry and has over 50 years of experience in aeronautics. So I will now hand over, I think, to Richard to kick off the webinar by taking us through some of the things that were discussed in the technology section of the report. Over to you, Richard.
Okay, good afternoon, everybody. I've been in the Greener by Design Committee for about 8 years, and for much of that time, the committee has been heavily involved in promoting Contrail's side of environmental sustainability for aviation. And that now, the good news there is that that's now been picked up by loads of other organisations, and it's been pushed out a lot wider, which is really encouraging for us. However, Greener by Design, since it started, I think 25 years ago, it also focuses on aircraft technology and operations as well. It's the whole suite of options that are available to improve and reduce aviation's emissions and its effect on the environment, or the negative effects. So the last 7 years, I've completed or written the technology section for the Greener by Design report, taking over from the late great John Green, who I'm sure some of you remember, who was also one of the founders of Greener by Design many years ago. And so most years we have a look through it. So we've always been looking at the technology, but again, with many more people now looking at the Contrail side of things, we're starting to look again a bit more about the technology side. So I've got a few slides I can share as I go along. If I can do that. I mean, they're just pretty pictures of aeroplanes. I ain't got to look at me all the time. Let's just try and get the sharing working. So one of the things we try to do every year is with doing this is to we look at three main elements is my usual sort of brief. So firstly, it's looking at conventional programs and conventional development sort of pathways. And the reason is this is really quite important. There's lots of talk around different types of novel propulsion, which we'll come on to a bit later. But really, while the current global fleet of airliners in 2050 will probably be no longer in service, there's 15,000 other ones already in the backlog, which we built and delivered in the next decade or so, maybe even beyond that, which clearly with a typical 25-year lifespan, those aircraft are going to be in service in 2050 and will form probably a significant proportion of the fleet. So it's important to look at what this conventional pathway is doing. And what's even more important, I guess, is you've got the likes of both Airbus and Boeing saying aeroplanes from about 200 seats upwards in Airbus's case, and Boeing a bit lower, 150 maybe, are saying, you know, that really the most likely scenario for these, at least after 2050, is going to be sort of SAF or kerosene fuel. So it's the same propulsion technology, just obviously made hopefully a bit better. So as part of our thing, we do look at what's going on, and so run around every year. So there's a few pictures on the right of the screen here. So I mean, really, some of the highlights, I guess, we try to pick out every year. So you know, so here you've got at the bottom, you've got the Comac C919 that achieved certification in China only, I believe, in 23. It's now into service with a few airlines. He's obviously building experience. I'm not sure what the plans are for, you know, certification around the rest of the world, but clearly it's a start that they've made. Also in China, further out for them is the C929, 929, which is sort of a 787 sort of competitor. Interestingly, there the Russians, it was a Russian-Chinese collaboration, but obviously with recent events, that the Russians are no longer a part of that, as far as we know. So it's now just the C929. So that's out there. This year, very big news for Airbus, I guess, was their certification of the A321 XLR, which is, you know, a 321 Neo. But obviously, this its defining difference, I guess, is its fuel tank, and there's other changes as well, which we're not going into now. But its plan really is to sort of tackle the longer range, extra long ranges, the XLR, obviously. It's to tackle that longer range, long thin routes, you know, sort of 3.5 to 4,000 miles. So that's its purpose. And the other thing, obviously, the ongoing story in Boeing. Okay, there's the 737 MAX stuff that's still going. There's the 7 and the 10, which are trying to get through certification still. But the other big news, obviously, in Boeing is their sort of continued pursuit of certification for the 777-8 and -9. However, I mean, one of the things I would comment on all these aircrafts, I don't really see any of them substantially improving the level of efficiency that's being delivered by other aircraft already out there. It's not improving the state of the art. It might do a little bit, but it's not there's no step changes coming along there. So the A321, you know, is a 321 Neo, you know, with bigger, you know, bigger, lighter fuel tanks. The 777-9 will clearly be somewhat better than, you know, 10-15% more efficient than the 777-300ER. But probably relative to the 350-1000, it's going to be, you know, a few percent either way, depending on the seat layouts you assume. The C929, I think on propulsion, I think they'll be looking at Western engines, which are 787 engines, so that shouldn't really go much further than a 787 in terms of efficiency, and similar with the C919, it's using similar engines to the 320 Neo, I believe. So those aircraft are out there. I mean, there are other improvements. I mean, I think the report talks about Embraer are targeting a sort of like a 1 to 2% improvement to their aircraft through various like aerodynamic and system fixes. So these are all improvements which are going, and these upgrade programs will happen and contribute, offering 1 to 2% here and there. There's quite a number of engine improvement programs around at the moment, but a lot of them are sort of targeting durability, you know, really to get the hyper efficient, or the very efficient engines that we now have on some of the on the newer aircraft types. You know, the temperatures and pressures in the engine have had to go up, and they're now sort of trying to make those engines last longer on wing between overhauls. So that's kind of where the focus is right now. And looking forward with this conventional path, I mean, and to me, if we take wide bodies to start with, thing that makes me feel old is I was around in the very early days on the 787 Trent 1000 program at Rolls-Royce. That'd be by early 2030s. That'd be 30 years ago, which starts putting that sort of aircraft, in my opinion, it starts putting it into sort of the time frame window for potential re-engineering with something newer. The A350 is sort of 5-10 years younger than that, so mid 2030s. Again, it wouldn't surprise me to see some programs coming along, looking at what they can do to improve performance of those. But I don't see on that in the wide body market. I don't see the likes of Airbus or Boeing going for a brand new centerline aircraft in the 2030s in that market. New engines and some improvements. You might get 5-10%, maybe hopefully a bit more. But it's an incremental improvement rather than a radical step change. I think this is fairly public knowledge. It's all out there over the last year. Change slides. Both Airbus and Boeing are talking 2035 and the sort of the single aisle market as being the next sort of place to go look at, which is not massively surprising when you think the 737 MAX is on its 4th generation of engines and airframe improvements. It first flew in the late 60s. Having said that, the 737 MAX fuel burn per seat sort of half of what the original aircraft were. So there's been some big improvements there. 320 was a newer airframe, but even that is sort of like a mid 1980s technology aeroplane. So you're starting to get to 40-year-old airframes. It's on its 3rd major iteration, its first sort of re-engineering reiteration. So it's by 2035, there's clearly something. There's a time frame there, and both Airbus and Boeing have sort of have been talking that sort of time frame as being something to look at. So there are a few pictures here just to help guide myself really, but I mean the Airbus have been talking 0E. So there's a in this market. So you've got a and again, Airbus did talk about this probably being lower than 180 seats. So it's a smaller end of the 320 market. They're talking here with hydrogen with that aircraft there in the top right. Fairly conventional air configuration. The wingtips look extended, and they're possibly some of these flapping wingtips that they've with Airbus and NASA Boeing have looked at in the past to take weight out of the aeroplane wing and to deliver improved drag. Airbus also put pictures of a flying wing and more advanced or ambitious configuration for that same time scale. We'll talk more about flying wings in a bit, but that's in their sort of publicity shots. Now, if I was Airbus, I'd also be doing. There'd be kerosene stroke SAF versions of these aircraft as well as a backup and as a baseline. But again, we haven't seen a picture of those, so I don't know if they exist or not. Boeing, on the other hand, have taken a slightly different approach and are looking at the out of the way at a truss braced transonic wing. So here they're going for much higher aspect ratio wings, as you can see on the picture on the left. With obviously, as you get long and thin and skinny on those wings, you need some support to under the critical load. So you have the truss bracing the wing. And these pictures aren't necessarily their 2035 configuration. This is the X66A demonstrator, which was being discussed over the last year. It's a pair of Pratt & Whitney GTF engines. It's MD 80 or 90 fuselage with the new wing, and I presume the empennage is MD 90 as well. And the idea is to Boeing to go fly test this and learn what they can, from that configuration. Clearly, this marketplace at the moment is interesting because I mean the market is sort of moving up towards the very top end of that size, so the 180, 200 seat market. And if you look at the 320neo family, they've sold 10,000 aeroplanes. Okay, 60% of them are A321s, and most of the others are 320. So clearly that is a big part of that market, and whether that is part of this or something different, we have to wait and see. again, so that's probably, so the big things that I see at this sort of time scale is, I mean, clearly the 737 and 320 are limited in terms of, they haven't got composite, you know, they've got aluminium fuselage and aluminium wings, primary wing structure. So, you know, composites or aluminium lithium are obvious things to go for. Aerodynamically, maybe laminar flow has got its time. Maybe, you know, the benefits start to outweigh the maintenance and the production penalties for having technology such as that. Yeah, some of the big things that might come along in that time frame. Other things are possibly reduce speed a little bit. We've seen the CFM RAeS engine, which is essentially an unducted fan. So it's essentially a propeller with a static second stage. Clearly there will be speed limits on the cruise speed of that engine, based, you know, just on the tip Mach numbers, and there's a compromise with efficiency. So there's a whole bunch of stuff to go on there. So we don't quite know where all that's going. So that's the conventional sort of pathways. So if we start looking more at novel things. So this last couple of years, I included this because, again, I like to see, you know, see programs of people doing stuff and flying stuff. You know, this clearly shows some sort of level of commitment and enthusiasm for concepts. So all those previous aircrafts, apart from the Airbus 0E, were pretty conventional in their layout. They're a tube and a wing, obviously with a brace maybe. So in the last year, there's been a couple of fairly big announcements. So it's Jet Zero, which is top right and bottom left. It's a US Air Force funded program. I think it was declared as a civil end use, but, you know, clearly there's always kind of crossovers. But so the bottom left, they've actually flew a fairly decent size scale model of that in the last year. There's a big contract that's going through. Yeah, that kind of configuration everyone talks about, having low aerodynamic drag, so obviously you get a big benefit for that. You know, the engines are the engines, so they are what they are, whether they're conventional or unconventional. I guess one of the great unknowns is really how much it's going to weigh. You know, can you create a pressure vessel in that shape and keep it light? Because the aerodynamics are good, but if you're flying something that's heavy, you still need more fuel to move it, more energy to move it. Also, during this last year or two, Bombardier have been looking and making a flight test of a sort of a more novel, or less conventional, let's say, business jet configuration. So it's more of a squashed, you know, sort of a stretched out sideways sort of center body, which I presume generates some lift. But for me, the real, I guess, benefits of this and the focus of this is low noise. I mean, having that U-tail that shields the engine exhaust, and having the wing shielding the forward arc noise is clearly a major sort of feature of that design. But those guys are out there, they're flying models, and, you know, how they develop in the next few years will be interesting. So that's novel airframes. Let's see if we can get on the next page. So we start looking more at sort of novel airframe, novel propulsion concepts. Get in the next slide. I'll come in a second. So clearly, the last year to me has seen quite a distillation, almost a crystallization of different concepts. So, which is for word. There we go. So on the battery electric, I mean, the thing that's taken headlines the last couple of years was the Aviationalis. They did a test flight, I think it was late 22, you know, with their prototype configuration. And this year, I think earlier this year, they announced sort of a design freeze more for their production variant, and it's changed a little bit. So it's not quite as a flat inverted sort of triangular shape. It's a bit more conventional in looking. You know, the nose looks more conventional now as well, I guess because of certification rules on pilot visibility. You still wonder about bird strike on that as a personal thing, but that's something I'm sure that they're looking at. So that's kind of where they've gone. So, but we haven't seen anything flying. The prototype hasn't flown since its first sort of 8-minute flight. So again, we don't know why or what's happening. But that may come along. But that really that seems to me at the moment to be where you know, battery electric seems to be. That's the kind of limit where it's kind of getting to. So in the last year, a couple of other bigger programs, or like bigger as in aircraft size, have sort of moved away from battery electric to more hybrid electric. So the last 18 months, I mean Aerospace over in Sweden, you know, they've been very busy, obviously. I think 2 years ago, the top right here, they had the ES-19, which was a 19-seat, 4 electric motor configuration that was fully battery electric. And I think it was maybe just over a year, 18 months ago, it sort of moved to the Heart ES-30, which is a 30 seats. They made the aircraft bigger. And this aircraft became a hybrid electric. So the big sort of canoe or fairing underneath the fuselage is where the batteries were stored. And in the tail, you can see an intake there. And there was, I think, one, possibly 2 turbo generators, gas turbine turbo generators installed in the back. And the view there, and the point there was very much, up to 200 kilometers, the aircraft would fly battery electric, fully electric. And its reserve, if it needed reserves, if it landed or it couldn't land, had to fly somewhere else or whatever and hold somewhere, it would use, it would start the gas turbines and generate electricity that would power the engines for the rest of the flight. So the idea is you load the fuel, but you never really intend to use it. That was the concept that they followed there. And more recently, and we'll come back to that whole reserve thing shortly because it appears in other aircraft. So with the latest concept, it sort of changed again, where they took the gas turbines from the rear fuselage and they put them actually on the wing, and they made the inboard electric motors and the propeller bigger. And what that's done, obviously, is it separates the gas turbine, the noise and any vibration from the fuselage. It frees up space in the rear fuselage, I think, for the batteries to go into. So again, that fairing is probably quite draggy, and also means a longer gear has sort of gone away. So it sort of makes a bit more sense. And the idea is that in normal flight, in this case, it flies fully electric on those inboard engines with the outboard gas turbine propellers feathered. And then when it needs them, it starts them. And this highlights one of the problems with electric propulsion is just that the battery technology is just not there yet. I mean, the range ends up being quite short. So you're looking at, sort of 200-300 kilometers maximum. Okay, is the furthest you could go. And when you're flying these short missions, you need the reserves. I mean, you need more, probably as much energy or maybe more energy remaining in the battery when you land to cover your reserve requirements. Okay, so I think at one point, I remember the ES-30 had 5 tons of battery on board for this hybrid electric model, which meant they need another 5 tons of battery for the reserve. So rather than that, they put what I think is probably about a ton of gas turbine and fuel in the rear fuselage. So they're getting a 4-ton saving, which makes it a better aeroplane. And this is a problem. So batteries are heavier at the current technology levels, especially, and then again, importantly, it's always pack level. Cell levels, I'm not worried about cell because they're a laboratory thing. Pack is what goes on the aeroplane, and they're usually sort of good, substantially worse or lower than the cell values. So that's a problem that they had, and we'll come back to that at the moment. Here we go. Next one. So again, there was also another aircraft we discussed in last year's report, the MAVE 01, and that I think was battery electric with distributed propulsion. They've now gone to the MAVE 80, so they've doubled its size. I think the original MAVE 01 was a 44 seat aircraft, and they've gone to a larger 80 seat aircraft. But it's now, I think it's parallel hybrid electric, so it's using batteries and gas turbines to do it. So it feeds power into the gearbox that drives propellers. So they also have moved away from full electric to hybrid electric. So there's this change, I think, in the last year on various programs that we think. So if we do one more, there's a bit further out. There's I'm just conscious of time. Further out, there's an Elysian aircraft, I think, over in Holland, and they're looking at similar. So they're looking at battery electric in the main mission, and again gas turbine in the tailplane to run for reserves, and that's their view. Now, another interesting concept this year was the Whisper liner. So this is a sort of I think it was a 100-seater, which these guys are doing an eVTOL concept, but they're looking at 2050 and battery electric. And the difference here is they commented on something which I kind of agreed with, that to make battery electric really work at this sort of 1500 seat sort of market, you kind of need 700 to 800 watt hours per kilogram to make it work. And that again, that's pack level, not cell, that's pack. And the idea then is, because the idea is that you're then starting to use a lot more of the battery's energy to carry payload, an aeroplane, rather than the battery itself, if that makes sense. If you're carrying 5-10 tons of battery on a 30 ton aeroplane, a good chunk of it's carrying itself. So again, that's something I think which is, it might come depending on it's very conditional on battery technology. Although, so whilst some of those concepts have gone from sort of battery electric to hybrid electric, but still with batteries being used substantially, hydrogen is also kind of coming along. So there's a lot of interest in various places. So again, we've got the Airbus concepts at the top there, and the lower one is a Fokker Next Gen. So again, the Dutch are very busy in this space. They're looking at and probably the two larger, so the two jet-powered Airbus aircraft and the Fokker aircraft are probably looking at hydrogen combustion. Because at that size, with high bypass engines or low specific thrust for my propulsion buddies, those engines their efficiencies approaching that of fuel cells. At the smaller end, so looking at small piston engines and smaller turboprop engines, those engines tend to have lower sort of thermal efficiencies. So at that point, fuel cell becomes of more interest, and there's more potential benefit in that market. But it seems to me that whole sort of 30 seat up, the fuel cells is something that's interesting. I think once you get above 100 seats, I do think that the combustion starts to become of greater interest. This is probably from the last couple of years. There's just a selection, and there's a lot more. And I apologise for anyone whose concept isn't shown here, but there's people like DLR have got a couple of programs putting fuel cells on a Dornier 228, which is the right hand side, a Dornier 328, or even the 428 Evo with the Deutsche aircraft program. The bottom left is Beyond Aero, who are a French outfit looking at a business jet, and Cranfield Aerospace. We're looking at a British Northern Islander, putting it on there. The last year we saw Universal Aero, who were on the face of it looked like a fairly sort of major player in the market, have ceased trading, citing lack of investment and unable to get the investment needed. Zero Aviation, on the other hand, seem to be hoovering up quite a lot. There's some fairly big programs that they're in. With, I think Airbus are putting money in. I think Rolls-Royce have sort of got a connection somewhere in some of the in there. There's a hydrogen and aviation program that Zero Aviation are in. I think Rolls-Royce, Airbus, I think Bristol Airport, and a few other players in that market. I look at GKN. Are all looking at in that market. They're also there's investment in places, but obviously Universal it didn't reach them. So again, there's lots of stuff to see where that side of thing goes. And again, all these aircraft tend to have engines which are turboprops at the moment, or small gas turbines, okay, which have relatively low thermal efficiency. So therefore, you put a fuel cell in, with sort of maybe 50% rough, give or take, efficiency. They can get substantial efficiency benefits over the gas turbines. So that's kind of where the novel side of propulsion, those two sides, and there's still other things for me, these demonstrators are all pushing ahead. Some will fail, some will succeed. The market will decide what this does. Recognizing both electric and hydrogen, both of them, there are challenges which are sort of beyond, I guess, the technology side. There's industrial and political challenges in terms of, can we produce enough clean energy to generate that hydrogen, or is it better used somewhere else, decarbonize another sector? These are all massive elements. To me, the one positive is to go back to the conventional aircraft, is you have at the start we said, there's 15,000 aircraft currently on order, and like almost 4,000 were ordered last year, and this year there'll be another 2,000 or 3,000 maybe, and maybe another 2,000 or 3,000 year after that. So there's going to be 20,000 plus aeroplanes in the market in 2050, and their only routes to reduce aviation carbon is SAF, contrail avoidance, and a bit of operational efficiency. Okay, so there's those are, and SAF, the SAF. I recognise there are huge issues of building as many power plants, as many production places for SAF, and all the myriad of pathways to generate it. But some of those actually do require substantial hydrogen production processes. So again, if the concepts do work, there might be some fuel around. I know it's difficult to transport, and it's voluminous, and it can leak, and there's issues with its global warming potential. Don't ignore all those. But on a technology level, these aircraft are looking at it, and if it works, then there's something there maybe. Again, I think those industrial problems are and the production of clean hydrogen is key. Safe electrics, as we discussed earlier, it's just getting those battery technologies up to levels that really start to offer the real clean sort of zero tailpipe emissions. But again, that requires a low carbon electrical supply to do that. So all that side. So that's very much the green side of it. As a technology review, we also look at supersonics, which again, by its nature, it burns more fuel per seat, a lot more fuel per seat than a subsonic aeroplane. It's just, it's a fact of life, I think. It's just physics. But there is interest out there, and their only route to truly green aviation is to use SAF, and you get into arguments whether there's better uses for that, but that's not for here. But in the last year, the Boom flew the XB1 demonstrator, that top left. That was an aircraft that's actually flying. They've flown it, which is quite an achievement. At NASA, they're looking for the X-59. That's bottom left. That's it's a quiet supersonic transport. So they're trying to create a supersonic, I guess they call it a thump rather than a shock or bang. So that's kind of where they're headed. So it's something which there's work out there. But again, in terms of the environment, I mean, you could argue these aircraft fly above contrail altitudes, but the amount of fuel they use per seat per mile relative to subsonic is considerable. I've not done the numbers, but I remember Concorde versus 747 that were sort of same sort of technology. The numbers are like 6 times as much fuel per seat. I could be wrong, but that's what I remember. So yeah, those are the sort of numbers you're looking at. Most years we also look at various we looked at various major research programs that are out there, but this year, I mean, I think a lot of the EU Clean Sky programs are in that sort of early phase of the current sort of round of research. So there's very few demonstrators who are actually out there doing stuff at the moment, but that will change in the next few years. In the EU, and so this year the focus really was on some of the airframe technology that's been going on. I think I'm getting towards the end of my time. I think I'll. So to me, what's going on for the next couple of years is that all these various programs. I mean, I've got to keep attracting the funding and keep convincing the investors that that they have a future and there's something in it for them. And they've got to start delivering and flying stuff with demonstrators. If you look at history, the report this year, I've gone back, looked at older reports at some of the planned first flight dates and people flying between this airport and that airport, and lots of them have been missed. And I'm not knocking those people doing it because it's hard. That's the whole point. Flying an aircraft making it a new aircraft concept fly is difficult, but certificating it and putting passengers on it is a magnitude, maybe even several more difficult. And that applies to any air vehicle. So the next few years, I'm looking forward to seeing what develops, what doesn't, and where we go. But at the same time, just seeing what happens in the conventional development path, what can happen there in terms of maybe re-engineering, and with that and the sort of the 150 market where that develops. So think the next 5-10 years will be very interesting to see what happens, and I think I await them with interest. On that, I think I'll finish.
Thank you very much, Richard. Nope. It's really interesting to hear what's going on in the world at the moment, with a bit of insight into what some of it might mean as well. So thank you very much. I can see a few questions coming in for you in the chat, and we'll get to those after our next speaker. So the Greener by Design Committee have been advocating quite actively for a number of years now around sort of contrail, managing contrails and how we can best do that. And towards the end of last year, they had a conference on that topic. So I'm now going to hand over to Ian, who's going to tell you a bit about the discussions and the content from that conference. Over to you.
Okay, thank you, Naomi, and good afternoon to everybody out there. I was reminded that actually this year was Greener by Design's 25th anniversary. It was 25 years ago that we started all this. And at that time, very few people were seriously worried about environment and certainly not aviation and the environment. How things have changed in the last 25 years. Initially, we were thinking about things like noise, and then it became CO2. And then about 10 years ago, possibly even more, the penny began to drop that there were other things going on that simply hadn't received any attention at all. And in the meantime, the narrative around aviation was turning ugly. Aviation is destroying the planet. No person with a moral conscience will ever get on an airplane and all this kind of thing. And so Greener by Design started to attack that as well, the negative narrative. But as we all know, and the last few weeks of weather have highlighted it yet again, the environment, the climate, is not waiting for 2050. It's already showing signs of more serious change than was anticipated. And so, again, from a Greener by Design perspective, we've asked ourselves the question, what can we do before 2050? What are the potential short-term interventions? And everything comes back at this stage to contrails, because the science, whilst there is uncertainty, is good enough for us to know that contrails are a big deal as far as the environment is concerned. Big enough, perhaps, to outweigh the effect of carbon dioxide. And so we needed to look at contrails. What can we do about it? Contrail management is a term that Greener by Design coined when it became obvious that simply avoiding contrails was not the right thing to do. This is because contrails come in two forms, some warm, some cool. And if you could possibly manage them, then you might be able to not only reduce the warming impact, but possibly offset some of the cooling from carbon dioxide. So this is a really interesting target. And what's been happening is there has been delay, even though the science has improved and action requires very little modification, at least in the early stages. And its effect is immediate. And its effect is immediately effective. It's not like carbon dioxide, which has many years worth of interaction in it. Contrails, we paint the sky white on a daily basis, and if we stopped painting it white, then the contrail effect would go away immediately. So it's a prime target. So our conference last year was all about contrail management, and the subtitle was Time for Action. And what we were looking for were reasons why action isn't being taken. And this was a year ago, and I'm very pleased to say that a lot of the questions that we raised have now been taken up. And as Richard said, other groups around the world have begun to realize that if they want to avoid demand management in the airline industry, they really have to have a plan B which can be deployed instantly and which will have an instant effect. And so we heard from the experts, the climate scientists, such as Professor Mark Stettler at Imperial College, about how detailed the understanding is now becoming. And of course, the detailed understanding allows us to be far more effective in the targeting of actions. We also heard from Professor Belouin of University of Reading that no matter how you look at the problem, doesn't matter what metrics you use, the answer is always, to a greater or lesser extent, do something about contrails today. We then heard about how you can observe contrails from space using satellite technology. Not easy. Artificial intelligence is something which is being drawn into this particular problem. Not easy, but again, essential if you want to verify the effects of any mitigation that you may introduce. There is also something on SAF, because the contrails are formed by particulates in the exhaust gases, and the particulates depend on the fuel. And therefore, the question is, well, what happens if we change kerosene for SAF? The news is that, well, it's a bit mixed. Some things look better, some things look worse. But of course, if you want contrail management, simply getting rid of contrails is not the best thing to do. So the jury's still out on the effects of SAF on contrails. We then heard from the Met Office and the meteorologists, and they said, well, the problem is predicting humidity at high altitude and also measuring humidity at high altitude. So these became the challenges for those who would provide the weather forecasts, which would allow the mitigation to take place. There have also been some trials, and we heard about the Maastricht trials where whole groups of aircraft have been moved around to see whether or not air traffic management can actually impose altitude changes. It's a trial of the operational system rather than anything else, but the Maastricht area is a particularly difficult one, and it was reasonably successful. So again, the future looks good. We also talked about the message, the communication of the message, because we were hearing that ministers in the UK from the COVID-19 had been, and I quote, bamboozled by the science. They didn't know what to do because the science that was being fed to them was so complicated. There were no clear messages, and they were terrified of making bad decisions. We're in a similar situation, it seems to me, with contrails. The people who should be in the position of making decisions have been bamboozled by all this. And one of the objectives of what we do is to try and simplify the message whilst retaining the accuracy of it, so that decision makers can be confident that they're making decisions which are not going to make matters worse. So basically, the whole thing was very, very positive. The climate science people were there, the operational people were there, the meteorologists were there, pilots were there. And at the end of it, we all said, we've got enough science to make a start. Why don't we get on with it? And since then, in the last year, a lot of other people have picked up the same message. And so the good news for today is we don't have to wait till 2050. We can do something right now. We're reasonably confident that we understand it sufficiently well so that we're not going to make things worse. And Greener by Design, I think, chalked up a little bit of a result there. So there we go, Naomi. Is that enough?
Thank you very much, Ian. Yeah, that's absolutely great. It's really good to hear about what's happening in the conference, and also that really positive news that you're seeing sort of good progress going on beyond that. So we're going to move on now to some questions and answers. I can see some questions coming up in the chat. If anyone else has any other questions, please do add them, and we'll try to get to what we can. I just wanted to start off, Richard, by asking you a little bit about the here and now, because we know that Airbus and Boeing have these huge backlogs of orders, and the potential emissions reduction just by sort of accelerating that fleet renewal to the current generation of aircraft is really sort of potentially quite large. Are you able to sort of point to anything that needs to happen or that can be done in order to sort of unlock this backlog of aircraft that need to be delivered and the emissions reduction that could come from them? Mute. You're on mute at the moment. Sorry.
Yeah, I mean the backlog is there, and it's a fact. I mean, it's those aircraft, and we keep being ordered every year for the next at least 5 years, I guess, because until you start getting new aircraft in a program actually running, people won't start ordering the newer ones. I mean, getting the fuel burn down on that, as we discussed earlier, it's Contrails is an obvious one we can do now with the existing fleet, and that's one of the reasons Green Island Design has been pushing it so hard. I mean, you know, even if it's the very bottom end of where the scientists are saying the effect is, you know, it's still, I think, 25-30% of the CO2 of effect. So again, going after that, there's nothing else on the table that can really sort of do that sort of numbers. So Contrails is one. As I said, older aircraft will be, you know, being parked up as time goes on. After COVID, a lot got parked up, but a lot of them come out again because supply chain problems have prevented new aircraft coming along. So that's not good for the environment. But unless you get what's going to trigger new aircraft programs is either going to be legislation that's never done it before, really, but unless, you know, there is an environmental demand, you know, that's required by the UN, or, you know, that's accepted globally. What's the incentive? Why would Airbus and Boeing in this current, you know, duopoly, now recognising COMAC are out there as potential challenges, but then they don't think they're not there in the next 5-10 years to really kind of push it beyond. But until, I mean, A320neo and 737 MAX only really happened because the C series was coming along, and that sort of pushed them into action. That and high fuel prices. So if fuel prices go high, that would drive a faster turnover in your aircraft. That might be answer your question.
Okay.
But it's also of course balance sheets. I mean, the industry is still reeling from all the lockdown effects. So they're trying to build a balance sheet at the moment. So there's very little incentive or will to go and do vast amounts of investment.
Yeah. Okay. So assuming that we do manage to unlock these sort of new aircraft programs, whether by whatever means, whether it's the market or legislation or whatever, what sort of technologies do you expect to see on that next generation of aircraft delivering sort of significant fuel efficiencies? Do you think that we're going to see a truss-braced wing on the next generation of aircraft, or an open rotor, I think is mentioned in the report as well? Or do you think that's going to be a level of risk too far for the OEMs?
I don't know. The challenge you've always got, there are a lot of these things that are small benefits. So there's people who talk about reduced design range or slower aircraft, which sort of, you know, offer significant but not massive improvements. You know, in sort of the 4 or 5% sort of numbers, maybe even less. The challenge is that within 4 or 5 years you can do the same performance with a much more capable aeroplane. So it's a whole bunch of stuff comes along like that. To me, the big hitters that are left, so on the single aisle market, weight, okay, so composite fuselage or aluminium lithium fuselage and wings are the things which aren't there in the 737 and the 320. Engine technology is starting to, you know, conventional gas turbines are starting to bump up against theoretical limits on their efficiency levels. You can go bigger but higher, lower specific thrust, you know, higher, more diameter on the fans. But again, there's weight and drag which pulls some of the benefits back. I mean, on the aerodynamics, I mean, there's I mentioned before laminar flow. Both Ian and I were heavily involved in laminar flow 20 or 30 years ago, and it was always been the next great thing. And the challenge always was it wasn't worth doing the cost to maintain it and produce those surfaces. Ian wants to join here, I think.
Ian wants to come in. Yeah.
I was just about to agree. I mean, I'm a lot older than you, Richard, as you know, right?
Yeah.
The truss-braced wing concept is at least 60 years old. Laminar flow control is at least 80 years old.
Yeah.
And the first question anybody should ask is, why hasn't it been done before? Yeah. And there's usually a very good answer. Now, laminar flow I mean, I was there. I know what killed it last time. It's the operational problems. It's not the physics, it's not the materials, it's not the manufacturing. It's when that aircraft gets out into the real world. And then you find that most of the time it does not work. And that's what killed it last time. And unless somebody can convince us that this won't happen again, then this stays almost in the realm of science fiction.
Yes, I guess it's good to keep revisiting these things, isn't it? And checking whether the technology and the science has moved on sufficiently for us to be able to implement some of these things.
Yes,
just sticking with
it also comes down though the fact that there's nothing else. There's fewer and fewer things that are as easily accessible. I guess is in the past they put winglets on the last generation. So it comes down to, if it's more cost, anything can be done if enough money's thrown at it. It's a question of when, if that is what's required, and it starts to become cost effective. If fuel price went up by 50-100%, say, because of suddenly there's vast amounts of SAF or something, suddenly money will be found to keep the aeroplane surface cleaner because it makes sense. But it's that thing of at fuel prices as they've been for the last 50-60 years, it's cheaper to burn a bit more fuel. So that's what's happened.
Okay, yeah, that's interesting. I guess we'll have to see how things transpire. But Ian, just coming to you again, there's a question from one of the attendees saying that the problem is obviously that the fuel has the aircraft has an optimum altitude to fly where it's burning minimum fuel, and that avoiding forming a warming contrail might cause you to fly at a non-optimum altitude. Did you want to tell us a bit about that sort of trade between sort of contrails and CO2?
Yes, I mean, it's a valid point. However, as those with the mathematical bent will know, at an optimum, the gradient is 0. And therefore, you can move plus or minus around an optimum with very, very, very small penalties. And we don't have to move the altitude very much. We're talking about 1,000 feet, perhaps 2,000 feet, in order for it to be effective. And the aircraft isn't necessarily flying at its optimum altitude because air traffic safety, etc., may have it in a non-optimum position. So it's a good question, but it's not an issue. Fuel can always be reduced, right? Okay. So the net effect can always be a very, very big beneficial impact on the environment.
Okay, that's great. Thank you very much. So I just wanted to move a bit over towards fuels. I know that it wasn't really the main focus of your technology, but getting quite a few questions coming in around both the availability of green electricity for both the generation of SAF and also green hydrogen, and that a lot of the hydrogen produced currently is not green, and where also the costs associated with them as well. So obviously, this is to some extent sort of out of the scope of our sector to sort of control things like energy supply and even fuel production. So what role do you think that the aviation and aerospace industry should be playing in trying to make sure that we do have the fuels that we're going to need in order to decarbonise and reach net zero? What do we need to be doing to sort of interact with the other sectors?
Good question.
We need to find an awful lot of money is the answer to that.
Yeah.
From somebody, and they don't seem to be rushing forward at the moment.
Okay, yes. Anything to add to that at all, Richard?
No. I mean, as you mentioned in the presentation, it's recognised as a challenge. And I've seen various questions down there, and they're all valid. It's that question of the problem with technology is if you go online and look at spectacular technology statement failures, you can see loads of stuff. People, people saying, "Oh, this is never going to work. That's never going to work." And, and 30 years later, they look a bit daft. I know there's laws of physics and other stuff, but there's things happen down the road. And I'm not saying I know the answers. I'm not saying anything is going to change like that. But it's that whole thing of where do you go from it? And one of the things I also think about is what's the best use? If there's a limited amount of green hydrogen, should we go and tackle current hydrogen uses first? Is there a bigger environmental benefit than for aviation. So aviation is then stuck with maybe kerosene. Maybe that's what it has to be. But it's sometimes I think we need to look away, and it's how do you generate these things and where can it go? And all aviation can do is look at this and say, at the moment, well, if there is some vast supply chain of SAF, say, to decarbonize the current fleet, and I don't know if, how, when, what, but if there was, a lot of those pathways involve producing hydrogen. So if you want to go hydrogen on aviation, and there's challenges there, you've got a ready, there's lots of ifs in there, but there's a ready supply chain for it. I'm not saying there would be, but if SAF is the route people are going at for the short term, for the large fleet that's going to be ordered that is going to use kerosene or SAF, it opens up the pathway to something else potentially. But again, the industrial scale of it is just massive, and like people are sort of commenting on that, and I think I'm not denying that in any way, but it's never say never.
And yeah, I mean, absolutely, it's going to be a big challenge for sure. Just thinking about energy sources, someone asking about ammonia, which has been proposed as an energy source on the aircraft. Did you want to comment at all on, you think, the feasibility of that might be?
I'm not really a fuel specialist, but it's pretty poor volumetrically, I think, ammonia, and again, there's issues of handling it, and it's yeah. I think I think Ian wants to say something. I'll let Ian in.
Yeah, it's a simple one. It's got nitrogen in it.
Yeah, NOx.
Okay? Therefore, when you burn it, you're going to get a huge amount of NOx. I mean, at the moment, the smart money is on avoiding any fuel that has a nitrogen atom bound into it. There's enough NOx coming out of the back because of the effect of heat on air, breaking air's nitrogen down, and we don't want any more. NOx is running third in the environmental impact stakes, but it's a nasty one, and therefore if you increased it, even at the expense of CO2, it would not necessarily be good for the environment as a whole.
Okay, that's great. Thank you very much. So we're coming towards the end. We've just got a few minutes left. So I just wanted to ask you both sort of one final question. If you can answer relatively briefly, that would be great. So is there anything that you don't see happening that you think is has real potential for meeting net zero 2050? Obviously, we've talked a lot about what is going on and the potential there. Are there any sort of missed opportunities, things that people should be looking at that they're not currently, that you'd like to see them focus on?
Well, obviously, I would like to see them focusing on Contrail Management as an active offsetting of aviation CO2 pool. See, the thing about CO2 is if you stop producing it, that doesn't change the climate situation because the pool of CO2 we already have is still there. What we need is something that gets into the pool and offsets some of the historic damage. And I don't think we're thinking hard enough about how to do that. Stopping it getting worse is one thing, but making it better is another target altogether.
Yes. Yeah, no, it's something definitely that we can look at. Richard, anything from you?
The other thing we haven't really discussed, I guess, is some of the operational efficiency. There's things to go out there, and Ian and I both recognise that there's fuel out there that you could probably avoid burning. We have different levels we think it is, but it's definitely this stuff we can go after. But saying that, a lot of the industry is doing a lot of that, and it's just trying to find ways to do that faster and better.
Yeah, no, absolutely.
That's a good
speed of doing all of this is going to be really very important. So we are coming to the end of our time. I'd like to say a really big thank you to both Ian and Richard for telling us about what's in the Greener by Design report this year. Hopefully it's whetted people's appetites to go away and read the full report. I'd also like to say thank you very much to everyone who's joined us. It's been great to see so many of you here. We've had an awfully large number of questions come into the chat, and I haven't been able to get to all of them. We just haven't had enough time, but we will take those questions away, and I think we'll have a look at see if there's any way that we can answer some of those sort of offline after the fact as well. Leah, my colleague who's been working very hard in the background with all the admin and everything, has been putting the link to the chat, to the report, and also our email address so that you can get in contact with us if you did want to have any questions. And it's also directed you to if you want to find out anything more about Greener by Design and the work that they're doing. So thank you very much. I really hope that you've enjoyed it and that you've learned something. And I'd like to draw this webinar now to a close. Thank you.